So now let's learn of a very interesting problem. Again, this is a very popular problem in most product-based company interviews, right? This is not a very hard problem, but neither is it a trivial problem. The question is all about, this is called the spiral order traversal of a binary tree. So imagine you are given this binary tree 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. This is a binary tree, right? So we know what is a level order of a binary tree, if you recall. So we have discussed this in the course videos also. A level order is nothing but you first finish off level 1. This is your level 1, right? You print your level 1. Then you print your level 2. If you notice, first I print my level 1. Then I'm printing my level 2 here. 20, 30. When I'm printing my level 2, I'm printing from left to right. I'm printing in this direction, right? 20, 30. Then I print my level 3. This is my level 3. My level 3 is also being printed left to right. Okay, 40, 50, 60, 70. Then I go to my level 4. My level 4 is also being printed left to right. So this is called as a level order, because I'm printing each of these in a level order and everything in one specific pattern, left to right, right? So if you think about it, so I'm printing everything from left to right. So this is your level order. Now, a spiral order is slightly tricky. Spiral order, you print the root. Root, whether you print it left to right or right to left, it really doesn't matter. Because if you think about it, a root is just a single node. So for the root, let's say we are printing in this direction. Okay. In this direction, right? From right to left. So from right to left. Next, the next level, I'll change the direction. So if you think about it, I went this way. Now I'm coming back this way. When I'm coming back this way, so if you think about it, I went this way, then I'll come this way, then I'll go this way, then I'll come this way. This is what spiral pattern or spiral order basically means, right? So now if you see, next time I'm coming in this direction. So I went in this direction, now I'm coming in this direction, right? From left to right. So if you notice, I print now 20 and 30. Very good. The next levels, because I came this way, I'll go back this way. So I'll go back this way, right? From right to left. Okay. When I go back this way, I print 70, 60, 50, 40. Look at this. 70, 60, 50, 40. The next level, I'll again travel in this direction. Again, I get 80, 90, 100, 110. So this is called the spiral order. Okay. So this pattern that I just drew, right? This, followed by this, followed by this, followed by this, and so on and so forth, right? So this is called the spiral order or the spiral traversal of a binary tree. Now the question given to us is, write some code or write the algorithm and the code to actually print given a binary tree in spiral order. That's the question. Now, before we jump into the question, again, if I don't want to jump into solutions directly, because that way you're not learning the skill of problem solving. The most important skill to learn here is the skill of problem solving. If I just give you a solution, you'll know the solution, but you'll not know how to arrive at the solution logically. Okay. So I'll show you missteps also while I'm trying to solve this problem. So first and foremost, very key observation in the strategy of problem solving is, given any new problem, try to map it to a problem that we already know. So this is called the mapping stage. Okay. So I'll try to break the problem solving approach into multiple stages. The first stage is called the mapping stage, wherein given a new problem, we try to map it to an existing problem that we already know. So we know level order. So spiral order and level order look very similar. They're not the same. But the closest problem we can think of that we have already solved, that we have already learned during the course videos, is the level order. So the spiral order, again, your level order is nothing but your BFS. Right? If you think about it, your level order, first I print 10, right? Then I print 20, 30, then 40, 50, 60, 70, 80, 90, 100, 110, so on and so forth. So if you think about it, your level order is nothing but your BFS. Because if you think carefully, a tree is also a special type of graph. We have discussed in the course videos, right? A tree is an acyclic connected graph. A tree is an acyclic connected graph, right? So BFS, which is defined on graphs, is also defined on trees, because trees are special types of graphs to start with. The only thing that we have to be careful of is, again, if you recall, this is the mapping stage, right? So we know spiral order looks similar, not exactly the same, to a level order. Level order is nothing but your BFS. And within BFS, if you recall, we use a queue. If you recall, in a DFS, we use a stack. BFS, we use a queue. Now, if I were to do level order using BFS, it's very simple. I create a queue. When I create a queue, I'll first insert my root node, right? Now, I'll remove the root node from the queue. Then when I add the children of any node, I add the left child first and then the right child. Because in a binary tree, I'll only have two children, right? The left tree, right tree. So in BFS, the order in which you add the next nodes is not clearly defined. If you recall what we discussed as BFS for a graph. But in the case of a binary tree, I have the concept of a left child and a right child, right? So level order is very simple. Level order is BFS, which uses a queue internally. Only that whenever I'm processing any node I'm processing, when I insert its children, right? When I insert its children to the queue, I insert the left child followed by the right child. Okay. So that's it. Then if you just follow this order carefully, and if you use BFS, you'll get level order. Very simple, straightforward problem. So, okay, spiral order. So the logic here is like this. Spiral order looks like level order. Level order is nothing but your BFS with inserting the left child followed by right child. BFS internally uses a queue. Very good. Okay. So now let's try to, because of all these mappings, there is one subtle change with the spiral order, which is in a spiral order, look at this, in this level, I have to go right to left in this direction. In the next level, I have to go in the opposite direction. In the next level, I have to go in the opposite direction. In the next level, I have to go in the opposite direction. So directly applying BFS itself will not work. So I need to somehow modify my BFS. Can I somehow modify my BFS by keeping track of the levels that I'm at? Okay, that seems like the most logical thing. So the first step is mapping. Second step that I'll tackle about. So first step is mapping. We've already mapped this problem to be similar to a level order, which is similar to a BFS with a queue. Okay, the second stage is let's try. The second stage is let's try our ideas. Okay, the first idea, again, when you try, we'll try it with examples because that's very, very simple to go through. Let's try out a few examples. Now the idea now is let's modify BFS while keeping track of the levels. Okay, so this is level 1, this is level 2, this is level 3, this is level 4. Okay, let's try to think how BFS works here. This is my root. Okay, so BFS we know uses a queue. Okay, let's assume this is my queue. Let's go through this idea. Again, in the interview, you will have to try multiple ideas. Some of them don't work, some of them work. With any idea that fails, you have to learn what didn't work so as to arrive at your next idea based on the failure of your previous idea. That's what is problem solving, right? See, the first step of problem solving is mapping a given problem to a problem that you already know. Then second, let's try and modify the existing problem because it's not exactly the same problem that we have solved earlier, which is your level order. Let's try to play around. Okay. So imagine this is my queue. Okay. First, how does BFS work? Again, I'll keep track of the levels here. I'll keep track of levels because the order has to keep changing. So first, okay. So let's look at this. This here I have to go this way. Here I have to go this way. Here I have to go this way. Right? That's the whole concept here, right? So okay, sorry. So okay, the other way around. So what did I print here? Okay, the other way around, right? So that's okay. So the way I want to do it is okay. So for 20, this I want to go this way. This I want to go this way. Here I want to go this way. There are multiple ways. Either this is also all right or the other way around is also all right. Okay. So I insert the queue. Okay. I insert 10 into the queue. Very good. Now I'll try to dequeue it. So I dequeued it. So I know 10 is at level 1. I'm keeping track of that. The 10 is at level 1. Okay. So now the next level I know. So if you recall, what is the answer here? 10. So I printed 10. Very good. Then I have to print 20 and 30. And since Q is a first in, first out data structure, I have to first put in 20. Only then I'll remove 20 first. So, okay. Now, since 20 and 30 I know will be in the second level, I'll insert 20 followed by 30. The left child followed by the right child. Okay. I'll also keep track that these two are at level 2. Very good. Now I'll dequeue 20. Okay. When I dequeue 20, look at this. I dequeue 20, I'll print 20. Okay, very good. I printed 20. Super good. No problem still now. Now, I know that since 2 is at level 2, its children will be at level 3. See, when this is being printed from left to right, its children will need to be printed from right to left, which means 20's children have to be added right first and then left. Because remember, this queue is a first in, first out, right? I should remove 50 first and then 40, right? So since I'm processing node 20 enough, because I just dequeued it, I printed it, I'll first insert or enqueue its right child now, because I know 20 is at level 2, its children will be at level 3, right? So I'll insert 50 here and 40, and I'll also keep track that these are at level 3. Very good. So 20 is done. Next, I'll dequeue 30. Okay. Again, I'll print 30 till now everything looks good, right? Now when I dequeue 30, look at this. When I dequeue 30, I know its children will be at an odd numbered level like 3, because this is at an even numbered level. So I'll insert its right child first and then the left child. Okay. Its right child is 70 and then 60. Okay. So I'll keep track that all these 4 are at level 3. Very good. So 30 is also printed. Now when I dequeue, I get 50. What should I be actually getting if you think about it? Look at this. What should I be actually getting? I should actually get, again, level order, right? Sorry, I don't want level order. I want spiral order. So 10, 20, 30 are done. What I want is actually 70, not 50. Look at this. When I dequeue now, I get 50. If I print 50, that's not valid, right? Because in the level order, I should be getting 70 first. Look at this. I should be getting 70 first, but I'm getting 50. Right? In my spiral order, I should be getting 70, but I'm getting 50. Which means this simple strategy, the simple idea that we tried, which is let's actually use the BFS queue itself while keeping track of the levels. Right? Look at this. When I'm at level 1, okay, which is an odd numbered level, I inserted left child followed by right child. When I'm at an even numbered level, I inserted right child followed by left child. Okay, that's what I mean by keeping track of the levels. But this strategy is not working out. So this strategy is not working. This strategy is failing us. Okay, this strategy is failing us. Now, very, very important part of problem solving is when you try a strategy or an idea and that doesn't work, understand why is it not working. Why is this not working? That's very, very important. Why is this not working? Because if you think of why this is not working, this will generate the next idea for you. Okay, look at how we arrived at idea 1. We arrived at idea 1 by mapping. Now we saw that idea 1 fails. Now we have to understand why the idea 1 is failing, because this will give you idea some direction for idea 2 instead of getting stuck. Okay, so when we go for idea 2, so let's understand why this is failing. So this is primarily failing because of this queue. So imagine instead of the queue here, think about it. What is the other popular data structure for this? For all traversal, stack. So imagine, see, this is where we failed, right? So let's focus on that a little more. This is where we failed. So imagine when I'm processing 20, okay, because we were processing 20, 30 and we failed at the very next level. Till here, everything was cool, right? So now let's assume I'm processing 20. Now, instead of inserting its children 50 and 40 into a queue, what if I insert into a stack? Now, what is the order that I want to print them? I want to print 70, 60, 50, 40. This is what your spiral, there are some numbers before that, some numbers after that. But this is the order in spiral order, right? Which means 40 should be printed after 50. So imagine instead of a queue, if I use a stack. Okay, then I'll first insert 40. Because remember, stack is a last in, first out. So first I'll insert 40, then I'll insert 50. Okay. Next, when I'm processing 30, I will insert 60 first and then 70. Now, when we're doing this, look at this. If I were to use a stack, what happens? That's what I'm thinking of, right? Queue didn't work out. Okay. Now, if I were to, again, I'm just thinking aloud here. Okay. If I were to use a stack, now everything seems to work well. First I get 70, then I get 60, then I get 50, then I get 40. Very good. So, since queue is not working out, the lesson learned here is, what are the alternatives? Okay, why is this not working? Because of this mess up with this order. When we learned why is it not working, let's think of simple alternatives. The simplest alternative seems to be your stack. Stack is working out. Oh, so it might so happen that this was just a trick question where everybody will think of queue because level order looks like BFS, but we might have to end up using a stack. Okay, so idea 2. Stack may work out. So let's think of the stack. Okay, let's think of the stack based solution. So let's assume I have a stack. I insert my 10 into the stack. Very good. I push it into stack. I pop it out. When I pop out my 10, again, I'm keeping track of my levels. This is my level 1. Again, this is my level 2. Level 2 has to be printed in this direction. Level 3 has to be printed in this direction. And so on and so forth. Level 4 in this direction. So, okay, I'm keeping track of my levels. My level equals to 1. Which means when I push the next time, I'll push 20 and 30. Okay, so I pushed 20 and 30. Very good. Right, now I want to pop. Look at this. Now I want to pop. Now when I want to pop, okay, if I push 20 followed by 30, 30 will be popped out first. But what is the actual order that I want? Let's write down the order. 10, 20, 30. This is a spiral order, right? 70, 60, 50, 40. And then 80, 90, 100, 110. This is the spiral order. Now 10, perfect. I pushed it, I popped it, I printed it. Khel khatam. The problem is solved. Okay. But what about 20 and 30? If I push 20 followed by 30, it will not work out. Because then 30 will come out first. Right? So this order is not working out. So what if I push? Okay, look at this. What if I push the right child first and then the left child? So I push the right child first and then the left child. So 30 and 20. Okay, very good. Now I pop 20. Okay, now I have to pop something, right? So now I pop 20. When I pop 20, I have to insert its children back here. Look at this. See, this is at level 2. Look at this. This is at level 2. I did right followed by left. So right followed by left. This was the idea when I was inserting into the stack. Its children, I know, have to be, what will its children be? Right? Look at this. How will its children have to follow? In its children also, 50 has to come first and then 40. 50 has to come first and then 40. So right followed by left. So now if I push 50, I would also pop it out, right? 40 followed by 50. No, 50 followed by 40. Then 40 will be popped out first. No, I have to do it the other way around. Okay, think about this. Okay, then I have to do the other way around. Look at this. The big headache here is that this is a last in, first out. Okay, that's what I have to be careful about. What is the order I want to print? I want to print 40 first, right? I want to print 40 first, which means 40 has to be inserted at the end. So first I'll print left, then right. So I'll insert left followed by right. Left is 50. Very good. Then 40. Then 40. Now 40 will come before 50. No, the other way around. Okay, this is a mess here. But that's okay. It's just a simple ordering, right? That's okay, no problem. So I'm inserting 40 followed by 50. Now I'll get 50 out, then 40 out. Okay, this order is now preserved. Cool. So here also I'm not doing left followed by right. Right? I'm doing left. So I did left followed by right. Yes, that's the right thing, right? Left followed by right. Right. That's the right way. Now when I pop, what happens now? I get 50 now. But remember, I wanted to actually print 30, right? Look at this. Look at this. 10 is printed, 20 is printed. See, I inserted 50 and 40 in the right order. But then, next item that I want to print is 30, not 50. So if I'm using this stack, the problem here is, without processing elements at a previous level, the next level is already competing for that. You got this, right? I hope you understood this. The next item that I have to print is 30, but 30 is down below here because I already inserted 40 and 50, which are the children of 20 above that. Now when I pop, I get 50. I don't want 50. I want 30. So stack is also failing. So stack is also failing us. Stack is also failing us. Okay. So what had just happened? We mapped it to BFS, which uses a queue. We thought, okay, maybe it will work with a queue with some hack by keeping track of the levels. Didn't work out. Then we said stack may work out. Because the lesson learned from idea 1 failing is the stack might work out. But the problem, stack is introducing a new problem, which is without finishing the previous level, I'm already arriving at the next levels. Okay, that's the problem with the stack. Right? Within a given level, stack is working well. Look at this. Within a given level, within this level, stack was working out well for us. But across levels, stack is failing. So stack is also failing. So now why is it failing? Because again, think about it. This is very important, right? Because a previous level is not getting finished, but the next level is already competing with it. So the problem is mostly with keeping track of levels. So lesson learned. The lesson here is the levels are messing up. The levels are messing up. Okay, the levels are messing up. Because without printing 30, 50 is already competing with this. That's what is the problem. So here comes the next big idea. Since levels are messing up, see, I know that till the time this level is finished, I should not even touch this level. Or I should not even bother about printing this level. So here comes a big idea. The big idea here is, what if I use 2 stacks? One stack didn't work, one queue didn't work. What if I use 2 stacks? Can I somehow make this work with 2 stacks? Logical. Again, this is not a big leap, massive leap, but this is an incremental leap. One single queue did not work. Again, we know that it's a traversal problem at the end of the day, guys. It's a traversal problem. Stack queue is a standard strategy for traversal problems. Single queue didn't work out. We failed. We learned it's because again, we realized from the single queue failing that stack may work out. Certainly single stack works at a level, but across levels, stacks are failing. So what if I try to use 2 stacks? One stack for one level, other stack for another level. Will that work out? Let's try. We don't know. Again, this strategy also may fail. But let's think about it, right? So what was the tree that we had? We had 10, 20, 30, 40, 50, 60, 70. So let's look at this tree. Okay. We can also keep continuing. 80, 90, 100, okay, 110. See, if we can make something work for these 3-4 levels, we can generalize it easily, right? So let's think of 2 stacks, right? So again, we don't know whether this will work. It may work. So I have 2 stacks now. This is my stack 1 and this is my stack 2. Let's see if we can make this work. So the idea here is, this is my level 1, this is my level 2. So different levels, let's keep them in different stacks. So let's say all odd numbered, let's keep them here. All even numbered levels, let's keep them here. Because the conflict only happens between 2 levels, right? It's only between 2 levels, right? This level and this level won't compete ever. Because till the time you don't finish this, see, by the time you start inserting these, even in a single stack approach, by the time you come to the grandchildren, right? All of the grandparents here. See, these are the grandparents, these are the grandchildren, right? The grandparents are already processed. So mostly the problem is happening between these 2 levels only, mostly. So let's see, let's work out this idea. So I insert 10 here. Very good. Okay, it's an odd level, so I insert here. Very good. So I can just keep track of the levels now. Now I remove 10. Cool. I pop 10 from S1. I print. When I pop 10, I know its children will be at an even numbered level. See, I know that they will be at an even numbered level, right? And this, I know that they have to be printed from left to right. So what I'll do here is, I'll insert the left child first, right? They have to be processed left first and then right. So if I first insert 20 and 30, because this is a stack, 30 will come out first. I want 20 to come out first. So first I'll do right child and then left child. Look at this. When I'm inserting into the stack 2, I'm doing right child first and then left child. Okay, let's make that note here. Okay, so 20 and 30 are done here. Okay, cool. So, okay, I know anything that is here is at even level. Anything that is here is at odd level. My stack 1 is empty. Nothing is there in stack 1. But my stack 2 is still there. See, till the time both stacks are not empty, my problem is not done. So I printed 10, cool. Now I pop 20. Okay, now I pop 20. I print 20 here. Now I know 20 is at level 2 because I popped it from stack 2, which means its children will be at level 3. right? Now let's see. Say I pop, so 10 is done, 20 is done. I printed 20. Now 20's children, in which order should I insert them? See, this is being printed this way. Level 3 has to be printed this way. It has to be printed this way, right? Which means 50 has to be on top of 40, which means 40 has to be below. So let me insert 40 and then 50. Okay, so what did I do? Left first and then right when I inserted into stack 1. Cool. So till now, no problem. Now, look at this. My stack 2 is not yet finished. See, now what have I done here? See, I know my stack 2 because I just finished 20. I know whatever is there in my stack 2 now. See, because my current level is 2. I know that. Okay, so I have to finish everything in level 2 before I come to level 3. See, if this is an even and this is odd, if I'm processing level 2, right now my level equals to 2. Right, which means now I have to finish this whole stack before I jump to this stack. Okay, now I'll do 30. Very good. See, this problem with a single stack, that was a problem with a single stack, right? The 30 got pushed under. So when I have two stacks, one for even numbered levels and one for odd numbered levels, this problem seems to be mitigated. So now I remove 30 or pop 30. So I print 30. Cool. Now what are 30's children? 30's children are at odd level, which means when I push them, I do left followed by right. Right? So which is 60 followed by 70. Now there is nothing left in my stack here, which is my even numbered level is completely finished. Yes, my even numbered level is finished. So I go to my odd numbered level. So my level now is 3. It's no more 2. My level is now 3. Right? Now let's pop 70. Very good. Things seem to be working out. Does 70 have any children? No. If there is no children, there is nothing to push. So done. 60. Very good. Things are working out. So this worked out. This worked out. 70, 60. Things seems to be working out. 60 do not have any children. So no problem. Then comes 50. Print 50. See, everything is working out, folks. Everything. Again, two stacks may work out. Again, let's see. Right? 50. So 50 has children. And 50's children will be at an even level because right now we are at an odd level. Which means its children need to be pushed here. Right first and then left. Right first and then left. Very good. So I pushed 110 and 100 here into the stack. Cool. My 50 is done. Right? My 50 is done. My 70 was done. My 60 was done. 50 was done. Now what about 40? Okay. The next element, obviously. See, till the time I don't finish this, I don't even go here. I make sure that this stack is empty before I go there. Because this is at level 3 and this is at the next level. Right? So I ensure that this is over. My 40. Okay, I print 40. What are the children of 40? Children of 40 will be 80 and 90. This I need to insert into the even numbered stack. Right? And how do I insert? Right followed by left. So 90 followed by 80. Look at this. Things seem to be working out. Now this whole stack is empty. My odd numbered stack is empty. My even numbered stack. Now when I push, I get 80, 90, 100, 110. So 80, 90, 100, 110. And none of them have children. So there is nothing to be pushed back into stack 1. Which means at the end of it, my stacks, both these stacks are empty. Look at this. This is working out. Magically, it's working out if you think about it. Now let's write the pseudocode for this and handle all the boundary cases. Right? So the pseudocode is this. Okay. S1 push root while both stacks are not empty. Look at this. While both stacks are not empty, if stack, again, this loop is if you're at an odd level. See, initially you'll always be at an odd level and then an even level, then an odd level, then an even level. That's why I've written the odd level first because we start with an odd level and then we go into an even level. So while the odd level is not empty, okay, you pop the element, you print the value, and then look at the order in which I'm inserting. Because you're at the odd level, right? Because you're at the odd level, its children, the right has to be inserted before left. Right? So first I'm inserting right. I'm checking if right is not null. I'm pushing it. Look at this. I'm pushing this into stack 2 now. I pop this from stack 1. Okay, because I'm processing odd level, the children has to be pushed to even level or even stack. Right? So when you push to even stack, first you process right, then left. Right? So when odd is empty, look at this. When odd is empty, the next thing comes even. I don't even have to keep track of levels because the levels are automatically there. First comes odd, then even, then odd, then even, etc., etc. And next, look at this. This is going to manage all the even stuff. When I see from the even stack, which is S2, I'm popping, I print the value. If I know the next level is odd, so I'm pushing it into the odd stack. The odd stack, first I have to push left and then right, as long as they're not empty, because I wrote this here, right? When you're pushing into the odd stack, left followed by right. When you're pushing into the even stack, right followed by left. We just discovered this. Look at how cool and elegant this algorithm is. See, once you arrive at this solution, writing these simple cases, this is straightforward. Okay, this is extremely simple. And finally, when both, see, within this while loop, you'll have these two while loops. Okay, this is just pseudocode. Okay, this is just pseudocode. This is not code in any programming language. Okay, very simple, very elegant code. Now, what is the time complexity for this? Let's see. Now, what is the time complexity for this? Very simple. Every element, if I have n elements, every element would get pushed either to stack 1 or stack 2 exactly once. So the time complexity is order of n if I have n elements. What about the space complexity? Imagine if I have a complete binary tree, if I have completely filled binary tree like this. Okay, completely filled binary tree. Okay, if I have a completely filled binary tree, this level will have approximately n by 2 elements, and all these elements at some point will be stored in one of these stacks based on whether it's an even level or odd level. So the space complexity is also order of n, because again, look at this, we are storing this information. See, when I'm processing this level, all of its children's information, I'm storing it in the alternative stack, right? Which means at most, given any level like this, I can have at most n by 2 children. If the tree is completely filled like this, which means the space complexity at any point will be n by 2, and order of n by 2 is nothing but order of n. So time and space complexity for this problem is very, very simple and straightforward. Again, the problem solving approach here that I wanted to introduce to you is as follows. Take a problem, first do your mapping. Okay, let me write it down. First step, map a problem to an existing problem. Map to an existing problem that you have already studied extensively. Okay. Next, modify. If the direct mapping doesn't work, then modify and try examples. With every failure, if you fail in this, learn why we failed. Ask this question. Now, once you fail, think of alternatives. What are the alternative approaches? And which alternatives might fix the reasoning behind this failure? Third, try the alternative. Again, alternative, right? So again, go back to step 2. Modify, try examples. Go. Keep doing this, right? And over time, you'll become pretty good at this. Okay. When you start off, you may not be very good. Again, algorithms and data structures is all about solving problems. I've seen some interviewees who just solve 1,000 problems. Again, let me tell you, I've seen some folks who solve 1,000 problems. They actually don't solve these problems. They look at the question, they see the answer, and they try to remember it by heart. The moment you give them a problem outside of these 1,000 well-studied problems, they will not be able to solve them, because they have not learned the skill of problem solving. Problem solving, first step is map it to something that you already know. Then modify it slightly. Try out ideas. Whenever you fail, understand why we failed, why it's not working. Then think of alternatives. Try out alternatives. Again, alternatives may also fail. Learn from the alternatives. What are the lessons learned from this failure? Now incorporate that into your next idea. Again, this sequence of ideas is an important part. How do you try out? See, mapping is more simple, right? But once you try out an idea and you fail, you have to generate the next idea. The generation going from idea 1 to idea 2 works out only if you can clearly diagnose why your idea 1 failed and being clearly able to think of alternatives. Look at our whole process here, right? We realize that spiral order is same as level order. Level order uses BFS with queues, mapping done. So I said, okay, idea 1, let's use BFS with some, while keeping track of levels. It failed miserably. The whole thing got messed up. We realized that instead of a queue, and I have an alternative which is a stack, but stack may work. So my idea 2 is stack may work. But when I use stack, there was this confusion between levels. So then the next idea is, one stack is not working out. What if I use 2 stacks? The next leap here was try to tackle the problem with 2 stacks, and everything worked. So we wrote the pseudocode, right? So this is the flow of problem solving, which you have to become comfortable with practice. Remembering, again, I've seen some interviewees who just know answers to 1,000 problems. So you just modify the problem slightly, they'll never be able to work it out. Okay, I don't want any of you to be those people who just by heart remember these solutions by heart. Okay, I want you guys to be able to learn this skill of problem solving, because now given any new unheard of problem also, you will be able to tackle it smartly. And that's what really matters.